we're looking at trigonometric values of special angles. So that means we need our special right triangles. So this is my 45. I have the matching angle over here. And that would be, for these, I don't need the x's. I can just use the value. So this would just be a 1, and a radical 2. Then I also have the other special right triangle as my reference. That would be, that's 60 down here, 30 up here, 1, 2, radical 3 for the 30, 60. All right, so basically the technique is we want to see where this lands on our unit circle, and then we'll apply the appropriate triangle that matches it. And we're basically looking like it was in quadrant 1, and they were thinking about the positives and the negatives for sine and cosine. Let's remember, sine over cosine is the same as y over x for the values. So sine is the y values, x is the cosine values. All right, so we're doing 240 degrees. So this is 0 and 360 degrees on our unit circle. This would be 90 degrees. Half a turn is 180 degrees. 90 plus 180 is 270. And then if we added 90 again, we'd get 360. And these are all degrees. A lot of times we just kind of leave those off, even though we probably shouldn't. All right, so where does this land? 240. Well, it's in the positive direction. So it's going to go all the way around, and we're not going to get to 270. All right, so we're going to land right here. So this is your 240 degrees, landing in quadrant 3. All right, in quadrant 3, x is negative, y is negative. All right, so these have to be negative answers, okay, as outputs, or as your x and your y. All right, so I'll just put x right here to remind myself, and I'll just put y right here to remind myself, and then might as well put the negative. Okay, so this one's going to be a negative, this one's going to be a negative. All right, and then we'll just apply the triangle to it. Now, the technique for these special right triangles is we always link it to the x-axis. We link it to this x-axis. So we're basically drawing a triangle touching the x-axis when we do these. So that means it would be this triangle here. All right, so what does that mean? It means I need to find out what this angle is, this angle just right here in, let's use a different color, in purple. So this angle right here is the one that I need. How do I find that angle? So I'll go ahead and I'll draw my triangle. That's the one I need. Here's my right angle. That's why we're doing it, so we can use the right angles. And then this is the angle that I need to know what it is. Okay, so the trick is, since we're comparing it to the x-axis, you either compare it to 0, 180, or 360, kind of whatever you need to do to link it to this axis right here. So which one would I compare it to? I would compare it to the 180 degrees. Basically, if I take off 180 degrees, then that's all that's left is this angle right here. So if I take off all that's rests right here, this 180 degrees, so I'm getting rid of all of this. If I take off all of those degrees, all I have left is that angle that I want. All right, so 240 minus 180. That's going to give me the angle that I need here. All right, and that's 60 degrees. All right, make sure you use a calculator if you're not sure. You don't want to do all this work and mess it up in your head doing arithmetic. So now I know this is 60 degrees. that tells me it's this triangle that I'm looking at. Okay, I'm not too worried about the 30 down here. 60 is basically what I need. All right, so I'll fill in all the parts. So between 60 and 90 here, between 60 and 90 is 1. The hypotenuse is 2. And the last side is radical 3. Okay? Remember, our answers are going to be negative when we plug it in. The first one is cosine. The second one is sine. So I need SOHCAHTOA. So, ka, toa. All right, switch to pink, a little better. Cosines first. So cosine is adjacent over hypotenuse. Let's do cosine first. Cosine is of 240 degrees is equal to adjacent over hypotenuse, A over H. Okay, so what's our adjacent to 60 here? And you can mark it if you need to. This would be adjacent. This is hypotenuse. And this is opposite. Opposite is across. Okay, we're dealing with the 60 or the 240, so all of it will maintain that. Adjacent to 60 is 1. Hypotenuse is 2. Well, that's easy. Cosine of 240 is 1/2. Of 60 is 1/2. The 240 means what? Don't forget, it's negative 1/2 because we're in quadrant 3. All right, so negative 1/2 here. Circle that answer for that one. And then sine of 240 is going to be the same as sine of 60, but I have to make it negative or opposite at the end. All right, so sine is opposite over hypotenuse. Sine is opposite over hypotenuse. Opposite is going to be radical 3. Hypotenuse is 2. Radical 3 over 2 would be the sine of 60, but we're doing the 240 in quadrant 3, so it's negative radical 3 over 2. All right, so for this one, negative 1 divided by 2. And on this one, it's negative radical 3 divided by 2. And just double check and make sure everything got typed in right. Everything looks good. All right, good job, great work. All right, so that's the technique, is we need to look at the quadrants and decide, is your x's and y's linking to your sines and cosines positive or negative in that quadrant? And then you're matching a special right triangle that would normally be in quadrant 1, and then changing the signs depending on which one we're looking for. All right, 225, it looks very similar. I just want to add one other thing. If we get a radical in the bottom, so this is just side work. Everything else is the same, but you can have an answer where you pop out with a radical in the bottom. You need to simplify your radicals. One of the rules is you can never have radicals in your bottom. You need to simplify out of it. So to get rid of a square root, you would multiply by whatever's exactly the same in the bottom. So I would multiply by a radical 2. You have to do that to top and bottom because that's your equivalent. This is just like a 1, so I'm not changing it. And what this does is the radicals combine on the inside. So this becomes a radical 4. Or like I've taught in class, you have a pair of 2's. All right, so the square root of radical 4, I'll just show it. Radical 4 on the bottom, and then multiply straight across and add radical 2 on the top. It is okay to have radicals on the top, not on the bottom. And then this would simplify into the square root of 4 is 2. Notice there's no more radicals on the bottom. All right, so if you ever have a radical on the bottom, you do have to simplify out of it and use the same techniques I just showed you.